Sir, we can wait for 2 more minutes. You can join. Sir, we can start it next.
Yeah, sure, sir. Good evening to all. I would like to welcome you all for this webinar on data analytics and its application. Myself, Dr. P. Sriramakrishnan, working in Department of Mathematics, Amrita Vishwa Vidyapeetham, Coimbatore Campus. Okay, so outline of this presentation is contains basics of data and types and form of data, basics of data analytics, tools and technologies, techniques and methods in data analytics, data visualization concepts, statistical method used in data analytics, application of data analytics, and career opportunities in industries. So this is the overall outline of this presentation. Let me start with my data. Okay, so data is nothing but it is a raw bits. Okay, data is actually stored in computer in terms of zeros and ones. Okay, so without computing the data, it is meaningless. So we have to compute that. We have to apply some computation technique on this raw data to extract some knowledge. Okay, then only it is more meaningful. Okay, so data has no meaning until it is processed and interpreted. Okay, so data refers to raw facts, figures, symbols that represent information or observation. So data is nothing but data is a raw bits stored in the computer. We have to apply some data analytic methods to extract the knowledge from the raw data. So this is the data overview, and then types of data. So in common, there are two types. One is qualitative data, another one is quantitative data. Qualitative data means it is a categorical data. So that is covered by descriptive or non-numeric value. For example, gender. Okay, the value of gender is either male or female. So male and females are categorical data. So are descriptive data. Okay, so another one of example is colors. So color may be any color, valid color like pink, red, blue, green. So these are all categorical data. So this type of data are generally called as qualitative data. Okay, so without any order. Okay, so another one category is the categories with meaningful order. That means rating. Rating means that rating is also categorical data, which has some values like poor, fair, good. So these are all the categorical data with some meaningful order. Okay, So this is the qualitative data overview. And then quantitative data means numerical data. Numerical data is just filled with some numbers or decimal digits. Okay, so these are all quantitative data. We can apply any statistical methods on this quantitative data. We can compute mean, median, mode, whatever we want. We can apply with this quantitative data. Okay, here we have two subcategory. One is discrete quantitative data. Another one is continuous quantitative data. So discrete quantitative data means that is the value is discrete. For example, number of the students in the class. So that is constant value, maybe 50 or 60 like that. So there is no interval here. So the 60 and 50 is a concrete value. So that kind of data is generally considered as discrete data. Okay. So second category is continuous data. So here the interval is here the upper and lower limit we can define, and then in between you can fetch any value. So that means that is continuous data. So here, for example, heights student height in the particular class. So the height may be start from 3 feet to 6.5 or 7 feet. So in between, all the students' heights are fall between that range. So that is the in between. Suppose you are picking one student means his height may be 5.6 something. So the value may be a continuous value, like temperature also. So for example, last 1 month temperature in particular city means that is varying from 60 Fahrenheit to 110 Fahrenheit like that. So upper and lower limit we know. In between, you can fetch any value. Means that is continuous quantitative data. And then form of data. Uh, in the computation aspect, the data may be formed in three different types. One is structured, unstructured, and then semi-structured. So structured data we know. Structured data means data all are organized in rows and columns like a table. Okay. So all the databases are arranged in terms of rows and tables. Okay. All the spreadsheet we know. So spreadsheets are it is just a row and column concepts, right? So this kind of data are called structured data. That means already the structures is defined. All the data types of each and every columns are defined. So we can fill the data to the spreadsheet or database. Then we can apply some computation on those data. So that is structured data. And the second category is semi-structured data. Here, here the semi-structured data means partial data are structured, or remaining data may be unstructured. Or user can define their own structure like JSON, XML, HTML documents. So these are all semi-structured data. So user they can define their own data type, their own structure. Okay, so that is semi-structured data. And the third category is unstructured data. Here the data format is not fixed. So we are going to integrate data from multiple sources. Each sources may have different types of data. For example, I'm just extracting images from one website. I can download videos from another website. I can read the text from another website. Means each source may have different format. You know, right? Image itself it has several format: JPEG, PNG, TIFF, so like that. Videos also they have different format like MPEG, okay, MP4, so like that. So different types of data we can integrate and we can apply some computation in that kind of data is called unstructured data, right? Then data analytics. So this is the let us come to our topic, data analytics. So data analytics is nothing but we are going to extract some pattern, trends, insight from the raw data. So now we know what is data. So I can apply some computation technique. The computation technique may be coming from statistics methods or some mathematical model, anything. So I can apply some techniques. That techniques will give some insights. Insights are hidden pattern from the data. Okay, so that is the definition of data analytics. Okay, this is the science. This is one separate computation science, which help us to analyze the raw data to make conclusion, to make the meaningful conclusion. That is the objective of data analytics. Okay, so data analytics is the science of examining raw data. Anyway, we are going to analyze the raw data only. In computer, it doesn't understand anything. It just read the data from the outsource, and our method only it can able to extract the knowledge from the raw data. Okay. It involves various techniques and tools to transform the data into actionable knowledge. Okay. The actionable is a key term here. It is very, very important term here, because the conclusion, whatever we are giving the as a conclusion, that conclusion is converted into some action taken on the particular application. Okay. So here the data analytics here techniques, it works based on statistics, computer science, as well as mathematical domain knowledge. This is the overall introduction about data analytics. The thing is, we are going to extract some knowledge from the raw data. The raw data may be any data. It may be a hospital data, it may be a transportation data, it may be a logistics data. The data may be anything, but we are going to consider all the data as a raw data. Okay. Okay. That data analytics definition. So the definition is the process. Data analytics is a process of collecting data from various sources, arranging the data as per our order, and then pre-process all the data, and then analyze those data to discover useful information, draw some meaningful conclusion, and that makes decision. Okay, that support decision making. So this is the definition of data analytics. It containing sequence pipeline process like data collection, data organization, data pre-processing, data analyzing, and then data knowledge mining. Okay, this is the pipeline flow of data analytics. Okay, then here we have several key steps. Whatever I told here, the same steps also given here. The first process is data collection. First, we need data. We have computation technique, we have computers, everything, but the major part is data. Okay, we have to collect the data from various sources. Like the sources may be anything. It may be a sensor data, or satellite data, or database data, something, social media data, or log data, anything. First, we have to collect all the raw data from different sources. That is the first step. The second one is data cleaning. The collected data may be incorrect data. Okay, so we have to clean the data. Okay, the data collection is the first phase. The second phase of the data analytics is data cleaning. We need to remove all the errors. We should remove duplicates. We have to handle all the missing values. Normalize, standardization, formatting, everything is included in the data cleaning. And then you can convert all the categorical to numerical, or numerical to categorical if needed, and then removing all the irrelevant information from the data source. Okay, so why the data cleaning is very essential here means it's playing a major role in the conclusion. If you are directly working with error data means your conclusion also is maybe wrong. So first you have to collect the data, then you should pre-process. Pre-process includes all those things. Okay, so that is nothing but data cleaning. So you should clean the data
Excuse me,
first.
sir.
Yes, sir.
Sir, sorry to interrupt. Students saying that slide is not changing. So have you
Okay.
changed the slide, or the same first slide only they can able to view?
Oh, sorry. I don't know why. Let me stop.
Yeah, stop sharing and can you share it?
Is it okay, sir? No?
Yeah, now it's changed.
Okay. 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 So the definition of data analytics is the process of collecting, organizing, processing, analyzing the data to discover useful information, draw some meaningful conclusion, and that makes support decision making support. Okay. So this is the definition of data analytics. Okay. Then key steps in data analytics, which includes data collections. So first we should collect all the data from different sources. The source may be different. Okay. The source may be a sensor data, or survey data, or database data, satellite data, or healthcare data. So data sources may be different. So first we have to collect all the data into one places. you can collect all the data into your local computer, or you can store it into any cloud service providers. Okay. Then the second phases of the data analytics process is data cleaning. Here you should remove your errors. Okay, the in real time data may have is not a clear data; it is a noisy data. So you have to apply several pre-processing technique to uh, remove this kind of errors. Okay, sometimes error may occur, sometimes duplicate value may occur, uh, and then you have to handle missing values. Missing values also playing a major role in the conclusion, right? So you have to deal with missing values, normalization, and then standardization, formatting the data, converting categorical to numerical, numerical to categorical. So these are all the things are comes under data pre-processing or data cleaning, right? The third phase of data analytics is data analysis. So here we can apply any valid statistical or machine learning models. Okay, so you can analyze available machine learning models. So which one is suitable for your own application? You can choose it and you can apply that method on your uh, pre-processed data. So that is phase three. Okay. The fourth phase is data visualization. So here you can generate after the third phase, you can extract the knowledge, right? Then that knowledge you can present in terms of graphs and charts. Okay. So data visualization is playing a major role in data analytics. So at the end of the scenario, you have to conclude all your knowledge in terms of graphs and chart. That which means that is more understandable from the end user or customers, right? So the fourth phase of the data analytics is data visualization. This is a very major thing here. And then fifth phase is decision making based on the knowledge extraction. Here you can improve your business or you can give some recommendation. Okay, so that is the decision making process. So these are the 5-step process we have with the data analytics process. Okay, then types of data analytics. Here it has 4 different types. Okay, so descriptive, diagnostics, predictive, and prescriptive. So these are the 4 different data analytics types here we have. Okay, the descriptive analytics means what happened in the past data. Okay, so descriptive analysis means what happened. It just summarizes the past data to understand what has occurred. For example, COVID data. Okay, in the COVID time, the several peaks are there, right? Suppose you are going to analyze the COVID data, what has happened in the past 1 year. So you can analyze those data. So this descriptive analysis is just nothing but what has happened in the past scenario, right? Here the several techniques are there, like data queries. You can write a SQL query to extract the data, and you can generate reports. You can apply some descriptive statistics, and then data dashboard. These are the techniques you can apply under this category. And then example like monthly sales report. You can extract the monthly sales report. You can see the website traffic summary over last 5 months or 10 months like that. And average customer age, everything you can extract from the post data. So the descriptive analysis is nothing but just I am going to process the post data to look into what is happened in the past uh, 1 year or 2 year like that. So the second category, the second types of data analytics is diagnostic analysis. So here, why did it happen? Okay. So uh, after applying descriptive analytics, um, I can apply diagnostics analysis. Here, it will ask one question like, why did it happen? So, for example, COVID data, last 1 year, why this many peaks are coming? Okay, the peaks are there, right? In particular time, the number of affected patient getting peaked, right? So, how many peaks are we have in the last 1 year? So, why did it happen? So, I can ask some questions. So, here several techniques are also available like drill down, data discovery, correlation analysis. Okay, several parameters we have. We can extract some correlation between those parameters. Okay, everything is comes under diagnostic analysis. The question is why did it happen? why did several peaks are happen in the COVID time? So I can ask the question. I can draw some conclusion. And then example is analyzing reasons for declining sales. Suppose one sales company they have means they can ask why did it happen, why the sales is declining in the last 2 months. So that is the diagnostic analytics. Okay, the third category here, predictive analysis. What is likely to be happen in the future? Okay, this analytics is going to concentrate on future. Okay, uses historical data to predict the future, forecast the future outcomes. That is the purpose of predictive analysis. Here, lot of methods also be there, like all the machine learning algorithm, statistical model, regression, linear regression, time series analysis, ARIMA model, data mining techniques. So, lot of methods also be there. You can apply that mechanism to predict the future forecast. Okay, for example, predicting the product demand. Okay, for example, the COVID case, what is the next wave occur? When will the next wave will occur? We can predict using the past records. Okay. So customer behavior forecasting, credit scoring, everything is comes under predictive analysis type. And the fourth category of data analytics is prescriptive analysis. What should we do? So this is the final analytics phase. So here we analyze everything past record and we also predict the future record, and at the end what we should do, how we can change our process. Okay, for example, sales company, the sales is declined last 2 months. Okay, what is the next 2 months sales I can generate, and under prescriptive analysis I can what should we do to improve the sales. So that is the fourth type of data analytics. So here it will give some recommendation. Based on the recommendation, I can do some action to improve my business. Okay. So that is the prescriptive analysis. So here also we have several techniques like optimization, simulation, data analysis. So and then examples are recommending the price strategies, inventory optimization, dynamic marketing campaigns. So these are the four different types of data analytics we have. Okay, so you can apply one by one to extract the knowledge. Okay, first one is applying descriptive analysis to analyze what has happened in the past data, diagnostic analysis for why did it happen in the past work, and predictive analysis means what is likely to be happen in future, and the prescriptive analysis means what should we do to improve our uh, sales or something. Okay, so these are the four different major types we have with the data analytics. Okay, then tools and technologies. Suppose I want to work with, I am very much interested with data analytics. I want to work with data analytics means you should learn about these things. Okay. For front end programming side, you must start with Python, or and then back end side, you just you should know the basics of SQL queries. Okay. So this is the programming tools we need, tools and technology we need. And then data visualization is also part of the data analytics, and here we have several tools to do the data visualization. Tableau, Power BI, these are the dedicated tools are available to do data visualization. Okay. Apart from that, we have two libraries like Matplotlib and Seaborn. Okay, these two libraries is help us to do the data visualization using Python. Okay, so these are the things we should know if you want to work with the data analytics. And suppose you are going to work with huge data, big data, means separate platform frameworks also available, that is Hadoop and Spark, as well as backend side you should start with MySQL and then MongoDB. So this is the overall packages for data analysis. Okay, so for programming side, you should start with Python and R. For backend side, you should know about MySQL, MongoDB, like that. And then data visualization part, you should work with Tableau, Power BI, Matplotlib, and Seaborn. If you want to work with huge data, you can go with Hadoop or Spark. Okay, then let me come to the techniques or methods. Okay, so I will cover step by step. First phase is data cleaning. So data cleaning, we already know it is helps to improve the quality of the data, raw data. Okay, the original data may be corrupted or incorrect data or missing data. So we have to apply several pre-processing technique to the raw data to improve the quality. That improved data may give the better conclusion at the end. Okay, so type of cleaning. First one is missing values. Okay. So missing values in the real-time scenario, we are collecting data from several sources. Sometimes missing values also be there. The field may be empty or incomplete data. First, we should deal with the missing values. Okay. So we have to fill the values first, and uh, then you can move to the second cleaning type, that is duplicate records. So duplicate records is also affect the conclusion. Okay, so repeated entries is take some time process, it eats some processing times. Okay, so you have to remove the duplicate record also. And then inconsistent format, for example date format. The date format may be different, right? Sometimes some sources they may have month year date, some sources they may give a year month date, like that. So sometimes they may use slash, sometimes they may use hyphen, like that. So inconsistent format may be available. So you should apply some techniques to remove this inconsistency from the data sources. That means you should use common format. Okay, date month year or year month date, unique format you should use throughout the data. And then unit also, sometimes they may filled with centimeter, some entries they may filled with meter or feet or inches, like that. So you should convert into common format. And then capitalization, some entries they may be entered with capital letters, sometimes they may enter with small letters. So you should convert into common format, any one common format. So that is the third type of data cleaning. And the fourth one is outliers. Outliers is very essential thing. Okay, outliers is nothing but odd man out data, anomaly detection. Okay, for example, age. Age is one column. You just assume that age is one column in my data set, in my data source. Okay, suppose age is filled with some minus 150. Okay, minus 150 under age is meaningless. Negative value under age is meaningless. So that is considered to be outliers. So extreme values that may disturb the analysis. So you should remove the outliers from the data sources. And then invalid data. Okay, data outside the expected range. For example, same age. The age expected range may be 0 to 120 or 130, like that. That is the expected year range of age. Suppose any values beyond that range, you should remove that. You should correct or remove that entries from your data sources. And then final data cleaning type is typo and spelling error. So in real world data may have some typographical error and spelling error. So you have to correct it through the code. This is not manual correction. I am talking about everything is only a automatic implementation. Okay, the second techniques under data analytics is data reduction. So in real world data is somewhat huge. I don't want to work with the huge data. I just want to reduce the data, means you can implement data reduction technique. So several techniques are available under machine learning uh, concept. So data reduction is a process of minimizing the amount of data that's need to be stored, processed, and analyzed. I don't want to work with entire data. I just want to work with simplified data without losing valuable information. Means that you can apply some data reduction technique. So what is the technique? Technique is dimensionality reduction or PC algorithm. Principal component analysis is a common algorithm used in machine learning to implement data reduction technique. Or you can go with feature selection, feature ranking. Okay, so feature selection means suppose 1,000 columns are there in my data set. I don't want to work with 1,000 columns. I just want to work with only 50 columns. So you can apply some feature selection method that will that will give top 20, top 50 columns from the data set. You just work with you just do your implementation with that feature alone. So that will save time as well as it will give accurate results also. Okay, so data reduction is one of the major phase in data analytics. Okay, here the name of the techniques and then description is also given. First one is the dimensionality reduction. It reduces the number of features. Feature is nothing but column. Okay, for example, age. Age is one feature. Name, that is another feature. um, location, that is another feature. Okay, so feature is nothing but column. Okay, so this dimensionality reduction that will reduce number of features. You can use PCA algorithm. Numerosity reduction, replace the original data with smaller representation. Okay, I don't want to work with entire data, so I'm going to work only with abstract representation. Abstract representation means, for example, histogram, clustering, regression model. So that will give some abstract representation of original data. And then third technique is data compression. So data compression is just nothing but compress the original data. For example, JPEG image. JPEG image is a data working based on the image compression concept. There JPEG image, zip compression. So that is also comes under data reduction techniques. As well as attribute selection, you can select some relevant attributes. So relevant fields, relevant features you can able to select from the data. So this is comes under feature selection methods. So that will remove the irrelevant column from the data set. Okay. Then aggregation, you can summarize the value into higher level. For example, suppose I have weekly sales data, daily sales data means instead of working with daily sales data, I can work with weekly sales data. That so the dimension has been reduced over here. Or otherwise, the sampling techniques, you can apply some sampling techniques to select some random sample from the data. So you can you can implement your process with that sample. So that is sampling techniques. And then binning method. Binning method is just like nothing but converting the continuous data into categorical bit. For example, age. So 18, 19, 20, all the ages at 18 to 25, all the ages I can consider as young. 26 to 35, I can consider as citizen. 35 to 65, I can consider as a senior citizen. So likewise, I can convert all the continuous to categorical. So this is the continuous data. After applying this binning method, my data set, my age column would be young, citizen, senior citizen, like that. So this is one type of dimensionality reduction. And then data transformation. This is the third techniques in data analytics. So data transformation is also a crucial step in data analytics, which involves converting data from um, original format into suitable format. Okay, so I am going to work with my data, so I can decide what is the format of my data. So original format may be anything. So after applying data transformation technique, I can convert into my comfortable format to do the data analytics. Okay, so the type of transformation may be normalization. Normalization we know, right? You can scale down the original data into 0 to 1. Okay, for example, age or mark. Mark may be the range is equal to 0 to 100. I can apply this normalization, means the outcome may be 0 to 1. Okay. Several techniques also available. Min max normalization, Z score normalization. A lot of normalization techniques also available. You can use it. And then standardization centers data around the mean with the unit variance. So standardization is always work with mean and then variance. So I can convert my data corresponding column is based on the mean and then corresponding variance. The technique is generally called as Z score normalization or Z score transformation. And then third technique is encoding. Encoding is just converting categorical to numerical. Okay, categorical means gender. Gender may have the values like male or female, like that. I can consider male as 0 and female as 1. So this is the way I can convert categorical to numerical. So that technique is generally called as encoding. And then filtering, you can remove the irrelevant or noisy data from your data set. So remove the record with null value. You can just delete those records, missing values, records, everything you can able to delete. That is the technique is generally called as filtering. And then fifth one is joining. Combines the data from tables or sources. You can integrate the data from different sources. Okay, merging customer transaction records, like that. And then discretization. Discretization is just nothing but convert the continuous data into a discrete bucket. Okay, for example, uh, uh, the similar it is similar like binning method. I am just converting continuous into categorical. So same technique is generally called as discretization. This is also comes under data transformation. And then for date time formatting, so In some data set, they may enter date, month, year like that. After applying these techniques, you can convert into year, month, and then date with filled with some hyphen. Okay, separated by hyphen. So this you can follow this unique uh, format to all the data. And then fourth technique is association rule mining. Association rule mining is a major technique used in data mining to extract the knowledge. Okay, it is help us to extract the uncover interesting relationship between the variables as well as pattern correlation among a set of items in the large data. So association rule mining is help us to extract the hidden pattern in the data, in the raw data. So common algorithm used for this technique is a priori algorithm, FP, frequent pattern growth algorithm, and frequent item set mining. So these are the few algorithms are available under association rule mining to extract the hidden pattern from the raw data. For example, market basket analysis. Market in the department store, they can analyze people, those who are buy a bread, they also bought a butter, so that they can store both. Okay, so they can find the frequency, they can find the relationship between the product. Okay, here bread and butter, they have a positive relationship. Okay, so that they can keep both. They can um, they can keep both butter and bread together, so that they can improve their business. So that is one of the major applications. Examples are available under association rule mining. So remaining applications are retail, e-commerce, healthcare, web analytics, and then banking. For banking, fraud detection based on the transaction. For web analytics, page click behavior by the user. And then health, in the healthcare industries, they can identify the disease based on the symptoms. In the e-commerce side, they can recommendation system. Customers also bought based on the customers buying behavior. In the retail shop market, they can implement market basket analysis, product bundling. Okay. The fifth one is predictive modeling or regression. This is generally called as regression or predictive modeling. Use the historical data to predict the future forecast. So here they can use the past data to predict the future outcomes. So here several techniques also available. One is linear regression, decision tree, random forest, and then XGBoost neural networks. These are the frequently used techniques available under predictive analysis. The application is the same application also be here: retail, healthcare, finance, marketing, and the manufacturing. So all kind of things here we can able to predict their future business. Right. So this is the fifth techniques are available here. Okay. So predictive is nothing but future forecast. Okay. For example, weather prediction, sales prediction, everything is comes under this concept, this data analytics. Okay, here a lot of variety of machine learning techniques also available, so you can use it and you can able to predict their business and the sales. Okay, so here we have several metrics to evaluate the prediction. The metrics are mean absolute error. Here we can predict the error only, because prediction result, actual results we have, obtained results also we have. In between we can compute the error. Okay, so evaluation metrics for prediction is mean absolute error, mean square error, root mean square error, R square, mean absolute percentages error. So this is the evaluation assessment metrics we have for regression or prediction. Okay, so here we can compute the error between actual versus obtained results. Okay, the sixth part of the data analytics is classification. Classification is one of the major techniques used in data analytics as well as machine learning. So here we can able to classify the uh, records. Okay, the classification may be anything. For example, if it is two labeled, only we have two classes means that is binary classification. If here we have multiple labels means that is called multi-class classification. For example, here we can able to predict a class. The so what is the difference between regression and classification? In regression, the outcome may be a continuous number. For example, age prediction. Age prediction means the output is a number. Age may be a 56 or 66. or 12, 13, 15. So this is the number we can able to predict from predictive model. So age prediction is just predicting a continuous number, but in the classification it is also similar, but here we can able to predict the class. Class is fixed one. For example, um, this email is spam or not. This is binary classification. If it is spam means I can able to predict spam. If it is not spam means that I can consider as 1. So spam 0, not spam means I can consider as class 1, class 0, class 1. So here the result is the final results may be a class, but in the regression, the final results may be a continuous number. That is the difference between regression as well as classification. So another example is tumor, cancerous or non-cancerous. If it is cancerous means I can assign 0 class. If it is non-cancerous means I can assign class 1. Okay, so class 0 and class 1 means that is binary classification, because only 2 classes are there. If only 2 class classification means I can generally call it as binary classification. For example, fraud or not fraud. Suppose more than 2 classes means I can generally call it as multi-class classification. For example, customer feedback. Feedback may be positive, negative, or neutral. Okay, if the feedback is 5 point, nearly 5, 2 point and 2.5 and above, I can assume that that is positive feedback. Less than 2.5, I can consider like a negative feedback. Equal to 2.5, I can consider as a neutral feedback. So three different classes are there: class 0, class 1, and class 2. So more than 2 means I can generally call as multi-class classification. So several classification algorithms also be there, like decision tree, random forest, naive bayes, support vector machines, k nearest neighbor, neural network. These are the frequently used classification techniques in data analytics. Okay, so here also we have several metrics to assess the classification model, like accuracy, precision, recall, effort score, and then confusion matrix. Okay, so here the outcome is a class. So how many classes are correctly predicted divided by total number of records or total number of cases. For example, my model is predicting 75 records correctly out of 100 means my accuracy is 75%. 75 divided by 100, that is equal to 75%. That is the accuracy of my model. So true positive, true negative, false positive, false negative. This is the pillar of the confusion matrix. Okay, these are all the basic things we should know about uh, evaluation metrics for classification. Okay, the clustering. Okay, then the seventh techniques under data analytics is clustering. Clustering is also a unsupervised learning techniques. Classification is a supervised learning techniques. Okay, so clustering is an unsupervised one. Here, it will try to find the distance between the data points together based on the certain features or pattern without pre-labeled outcome. So clustering is nothing but grouping the data based on their distance. Okay. For example, in the class, 60 students are there. I just want to split it into three different groups based on the CGPA. Okay. Based on the CGPA, I can create three different groups. First group, slow learner, average learner, and then fast learner. I can able to create three different groups based on the CGPA. So, how can I segregate the CGPA? Based on the similarity of the CGPA together. Okay. For example, CGPA 5 to 7. I can I can club it into one group for slow learner. 7 to 8 or 8.5 average learner. 8.5 to 9.5 or 10 fast learner. I can group the students based on the CGPA similarity. Okay, so cluster is working like a similar way. So it helps to reveal hidden structure in the data and commonly used in data segmentation, anomaly detection, recommendation system. Okay, the common algorithm used under clustering is k-means clustering, hierarchical clustering, DB scan clustering, like that. Okay, the application of clustering, which includes marketing. Okay, they can segment the customer based on the purchasing behavior or the demographic details. Okay, and then in the healthcare industries, patient may be grouping based for the personalized treatment based on their symptoms. And then in the retail business, product recommendation and inventory grouping is the use case. And then for cyber security, anomaly detection and fraudulent activity detection is the use case. For image analysis, object segmentation from the images. Okay. for social network community reduction in the graph. So these are the several use cases are available for clustering in data analytics. Okay, the eighth topic is data. Text analysis using natural language processing (NLP). So we are not going to work only with numbers and values, images, video. We are going to work with text also. So analyzing the unstructured text data is also very essential thing. Okay, then only we can understand the text and we can give some recommendation. Okay, example for this thing is chat gpt. We can ask some test queries in terms of text. It will analyze those text and then it will give some recommendation, it will give some results, right? So that is the concept called text analysis. Okay, all the chatbots. So nowadays, chatbots is working available in all the business as well as e-commerce sites. So you can ask some questions. It will give some recommendation. It will give some suggestion or solution. Okay, so that is the text mining. It is works based on the natural language processing as well as large language model. Right. So here techniques are sentimental analysis, tokenization, named entity recognition, and then topic modeling. These are the techniques are available under NLP. Okay, the application of text mining, which includes information extraction. I can extract the information from the given document. Like I can extract, I can send a WAD document or a PDF document to the NLP model that will extract names and dates from the data documents. Okay. Then text classification, I can categorize the text like spam detection, sentiment analysis, everything I can do with the things. And topic modeling, discovering hidden themes in the document. Sentimental analysis, I can determine the emotional tone. For example, suppose I am just uploading customer feedback to my model. The model can analyze all the text and then it will give the results like positive, negative, neutral feedback. And then named entity recognition, which includes identifying the entities like person, organization, location, email ID, like that. And then text summarization. Nowadays, many models are available for summarizing the text. Suppose one book I have, which containing around 25 to 50 pages. I don't want to learn all 250 pages, so I can create a model. That model will summarize the text, okay, from the longer documents. That is text summarization. And missile translation. Translating the text between different languages. Nowadays, a lot of translators are available in the online. It will translate the data from one language to another language, like Hindi to English, English to Tamil, Tamil to Hindi, like that. Right? And questioning, answer, and chatbots. Nowadays, many chatbots are available in all kind of business, which is available in 24/7. That is a major advantages over here, and which understand the human inputs, and then it will generate the recommendation, suggestion, and solution like that. So these are the applications are available under text analysis. And then ninth part of data analytics is anomaly detection. So anomaly detection is nothing but odd man out data. So we can find the odd man out data in the transaction in the data set. For example, it will identify the unusual data point that differ from the normal data. Okay, so which includes several techniques like Z-score, isolation forest, autoencoder. These are the common techniques are available in the anomaly detection. For example, Z-score. If Z-score value is greater than plus or minus 3 means that I can assume that that is the anomaly data. So here also we have several application like fraud detection. Fraud detection is used in the banking and financial sector. Cyber security threats. Okay, detection is available. It can able to identify the DDoS attacks. And healthcare monitoring, it will identifying and detecting the abnormal patient vitals or medical test results. And then manufacturing side, it will spot the defects and machine failures in the production line. And then retail and financial line, it will analyze the customer behavior, and it will identify the sales spikes or drops. And IoT and system monitoring, it will identify the sudden CPU use, memory, and sensor anomalies. These are the use cases applications under anomaly detection. And the last techniques under data analytics is data visualization. So this is a very important part of the data analytics. Anyway, we are going to present our conclusion in terms of charts and graphs. Okay. So why we need to present in terms of charts and graphs means that is very easy to understand by the end user. That can be easily understood by the end user or customer. Okay, so data visualization is nothing but graphical representation of data, uh, not the data, graphical representation of knowledge mining to help the stakeholder to understand the patterns, trends, and insight quickly. Okay, it is a core component of data analytics which supports exploration, storytelling, decision making, and communicating insights through the visuals. Okay, so several tools also available. Dedicated tools also available for data visualization. So the tools are Tableau and Power BI, and several packages also available under Python like Matplotlib and Seamort. Okay, the application of data visualization, which includes several techniques like you can present your data in terms of bar chart, line chart, pie chart, histogram, box chart, scatter plot, heat map, count. These are the frequently used data visualization techniques. So these are the frequently used techniques. Apart from that, we have a lot of data visualization techniques also be there. Just please explore all those techniques. Each techniques they have their own unique characteristics. Okay, let us discuss one by one. So first bar chart. Bar chart is look like this. Okay, in the x-axis we can plot the categorical column, and in the y-axis we can plot the numerical values. So this graph is means that disease-wise patient count. For example, diabetes, how many patients? 120, 130 patients. Hypertension, 150 patients, like that. So disease-wise patient count I can plot using bar chart. Okay, then line chart. Line chart in the x-axis you can give some categorical. In y-axis you can give some numerical values. So this is a use case for website traffic over the month, January, February month. Okay, so January, February month the website traffic is slightly low, and in the March month the website traffic may be a high. Okay, so this is for line chart. And then scatter plot. So here x-axis also a numerical value, y-axis also a numerical value. So this is a scatter plot. I can plot any dots over in the xy plane. So this is a use case for student performance based on the hours studied and then exam score obtained. Okay, in the x-axis you can plot hours studied, and in the y-axis you can plot corresponding exam score. For example, student those who are studied around 10 hours per day, they got around 45 marks out of 50. Okay, student those who are studied 2 hours per day, they got around 10 marks out of 50. So this is the direct relationship between hours uh, studied versus exam score. So in this case you can use scatter plot. And then pie chart, it is a very familiar chart. So here we can able to plot all those uh, values in terms of circle. Okay, so here all these values are computed in terms of percentage. Totally 360 degrees are there. So based on that contribution, it will split the, it will assign the percentage. For example, this is a smartphone market share on 2025. So here Samsung is occupied around 30%. Sorry, Apple is occupied around 30%, Samsung 25%, GM 20, like that. Okay, this is the pie chart. And then hit a histogram. Histogram is look like a bar chart, but here the thing is in x-axis it will automatically create a bin. Here actually 15 bins are there. Each bin, how many values are fall between the particular bin. For example, this is the bin from 10 to 12 means how many values are fall between that range means around 2 to 3. Here 40, 38 to 40, how many values, how many records are fall under this range means around 32. Okay, so in the x-axis is a bin, and in the y-axis is the number of records comes under particular bin. Okay, so this is just a count the number of customers and then corresponding age distribution. Okay, so the use case is age distribution over the number of customers. For example, 40 age number 30 to 40 is peak in the retail store. Around 32 customers are uh, fall in the range of 38 to 40. Okay, so here it is very minimum around 50 to 57 to 53 to 54. The number of customers is around 3. Okay, so this is the age distribution over the number of customer count. And then plot box. So this is also looks similarly like bar chart, but here it is works based on the percentile concept. Okay, so in the x-axis is a categorical, the y-axis is a numerical value. So this is works based on percentile concept. So monthly sales revenue distribution by a region. Okay, there are 4 regions are there. So each region monthly sales distribution is mentioned like this. Okay, so here a lot of lines are there, right? So this is 0th percentile, this is 25th percentile, 50, 75th, and then 100 percentile. So this concept, this chart is works based on the percentile concept. Okay. So some dots also be there. The dot means that outliers, odd mean out data in the data set. So here you can use box plot to deduct the outliers. So this dots and all means that odd mean out data in the data set. And then violin plot is also works based on the data distribution. So here um, X is a categorical data, Y is a numerical data. Here the use case is employee sales distribution by the department wise. So here 5 departments are there: IT, HR, sales department, marketing, and finance. Okay, this is the corresponding employee salary. Here in the IT sector, more number of employees they are getting salary. Highest is more number of employees they are getting. Average salary is around 60,000 to $50,000. Okay. Likewise, HR, more number of employees are getting around $50,000. In the sales department, also $50,000, but it contains a long tail. That means some people are getting around salary around $90,000. So this is works based on data distribution. And then finally, heat map. Heat map is works based on the linear relationship, correlation coefficient between the linear correlation coefficient between the numerical fields. Okay, so this heat map is always works only with the numerical columns. Okay, for example, this is the sales data set. Here, how many numerical columns are there? 5 columns are there: revenue, profit, units sold, customer rating, advertising, spend. Okay, so what is the relationship between revenue versus revenue is 0. That means strong relationship, because revenue versus revenue means there is no deviation, right? So that it obtain 1. 1 means that will filled by red column, because here this is the corresponding color scale. 1 means it will occupy with filled with red. So revenue versus profit. What is the relationship? Minus 0.02. That means negative relationship. Revenue with units sold, the negative relationship. Revenue with advertisement spend, positive relationship. Likewise, each relationship we can able to obtain, you see, heat map, and each cells are filled with the corresponding color scale. For example, 1 means dark red, 0 means dark blue. Okay, then finally, text mining. Under text mining, we have several data visualization methods. So word count is one of the frequently used data visualization techniques in text mining. So this is the word frequency in the customer feedback. Suppose I have one document which containing around 150 customer feedback. I can upload the document to my text mining model that will extract all the content, and that will extract the frequently word used by the customer, and at the end I can plot a word count like this. So here, great and service, that having very big font size. That means most of the customer they are giving feedback with great and service word. So that the overall feedback for this customer feedback for this input is positive, because they are giving great service as a most bad frequency in the feedback document. Okay, this is a bad frequency. And here we have several statistics methods also used in the data analytics. Again, statistics method is also very essential tool to collect, analyze, present, and organize data. So the techniques are descriptive statistics, inferential, probability distribution, Bayes theorem, time series analysis, and the multivariate statistics. These are all the part of statistical method in data analytics. So descriptive statistics, we very well familiar with the descriptive statistics. That is nothing but mean, median, mode comes under central tendency. Range, variance, and deviation comes under dispersion, and then frequency distribution, histogram, box plots are comes under data distribution. These are all part of descriptive statistics. And then inferential statistics is everything is make a prediction is based on uh, the prediction is based on some assumption about the population based on the samples. So here we don't want to work with the population. Here we can collect some random samples and you can implement your process. Okay, the techniques are hypothesis testing, confidence interval, and then p-values, z-score, t-score, sampling methods are part of statistical techniques, inferential statistics in data analytics. And then probability distribution, we know lot of probability distributions are available. So you can utilize this probability distribution in your data analytics process. Normal distribution, binomial, Poisson, and then exponential distribution. And then Bayesian statistics also is essential in data analytics. It probability supplies that incorporate period knowledge along with the new evidence. So you can use the Bayes theorem to implement the Bayesian statistics. And time series analysis is very essential, playing a very essential role in data analytics. So here it is help us to predict the future. Okay, so you can use moving average, exponential smoothing, ARIMA model to predict the future forecast. And then multivariate statistics. So here also it will work with multiple variables simultaneously, like principal component analysis is also part of multivariate statistics, factor analysis, cluster analysis, and the discriminant analysis. These are the techniques are available under multivariate statistics. And then finally we are coming to the application part of data analytics. Okay, application of data analytics in healthcare, which includes which help us to enable the better patient care, disease prevention, and resource optimization. Okay, for example, hospitals can analyze the patient data to identify the high risk individuals, and then they can provide the personalized treatment plan to each and every individual. Okay, so these are the applications of healthcare. And then applications of data analytics in finance and banking. In the financial sector, data analytics plays a crucial role, like fraud reduction, risk reduction, risk assessment, investment strategies like that. In the banking sector, they can process a large volume of transaction to find the suspicious activity and predict credit worthiness and optimize the investment portfolios. So everything is automation, right? So nothing is nothing in manual. Everything is automated process. And data analytics also enables personalized financial advice to each and every individual customers, and then development of creative financial product and then service. Right. So applications of data analytics in cyber security, which includes which prevents cyber threats and attacks. Okay. So it can analyze network traffic's user behavior and then system logs to identify the anomalies and potential cyber security breaches. Right. Applications of data analytics in the logistics and supply chain management is it is playing a crucial role in optimizing the transportation routes. Okay, source to destination is just optimizing the route and managing the failed operation, improving the overall supply chain efficiency. So this kind of mechanism they are using in all kind of e-commerce business, right? And then they are using these techniques in shipping, like that. So logistics companies can minimize the cost, reduce the delivery time, enhance the customer satisfaction by analyzing data on routes, delivery times, real-time online updation, and then vehicle performance. Okay, so this is one of the major area in data analytics. And then application of data analytics in retail businesses, which provide the insights into the customer preference, optimizing the pricing strategies, and improving the inventory management. Right. So retail analysis, which includes sales data, customer feedback, market trends to identify the popular products, personalized offer, and then forecast demands. Okay, so it can help retailers enhance their marketing effects, improve the customer loyalty, and then optimize the store layouts. And then applications of data analytics in manufacturing, which includes enabling the predictive maintenance, okay, periodic maintenance, optimizing the production process, and then improve the product quality. Uh, so manufacturers can predict the equipment failures, minimize the downtime, ensure the efficient operation by analyzing the sensor data, the historical maintenance logs like that. Okay, so data analytics also enables real-time monitoring of production lines, leading to higher productivity and then cost savings. Okay, so these are the applications we have with the data analytics, and we have several challenges also, like we have to deal with inaccurate, incomplete, and inconsistent data, which can lead to misleading insights. Okay, so combining data from different sources is very complex task. Each data source they have their own format. Okay, the integrating data is very difficult here. And then protecting sensitive information while ensuring the compliance with regulation as per the government norms is very difficult one for under the data analytics. And shortage of professionals with the strong analytics knowledge, statistical and then domain knowledge. And rapid evolution of analytic platform and technology is one of the major concerns here. So the developer or the engineer should update their knowledge based on the day-to-day platform and technology updation. And then few more challenges also be there, like translating complex data finding into actionable business decision. Okay, complex data, raw data into actionable vision decision is very complex task. Okay, sometimes they have to work with large scale data set efficiently. Okay, in real time data is not a data like Excel or data sets or database. So real time data may be a streaming data or live data. Okay, so they have to work with the live data also sometimes. The complexity is slightly high. Data and model bias can be lead to unfair and inaccurate outcomes. Okay, so lack of data driven culture or resistance to the change. Okay, analytics initiatives can be expensive and time consuming. Okay, so these are the major challenges in data analytics. And the future direction of data analytics is it is in they are increasing the automation through the AI and ML. Okay, data analytics is uh, the future direction is focused with the AI and ML, and support proactive and optimized decision making. And it is growing importance of ethical data use because they are collecting data from different sources. Sometimes users personalized data may be involving. So growing importance of ethical data use. Enhanced natural language processing for data insights. So these are the future direction of data analytics. And finally, the career opportunities in industry for data engineer. Okay, so this is the data I obtained from different sources like Ambient Box, Greeks, and Simply Learn websites. Okay, so the career opportunities for data analyst in industry in different roles. They are acting different roles like data analytics, data scientist, machine learning engineer, business intelligence like that. So the corresponding skill set also given here, like data analyst means they have to very much strong with Python or Tableau, Power BI, and statistics concept. The average salary is around 6 to 9 in initial stage. Okay, so data scientists they should strong with Python and all. Here you can see Python and R is repeating. So for data analysis, you should more strong with Python as well as R. For data visualization part, you should strong with Tableau, Power BI as well as Python. On the concept basis, you should strong with statistics and then mathematical methods and then ML algorithms. Okay. So for data scientists, the average salary is 13.5 lakhs per annum, and machine learning engineer 10.8, data business intelligence analysis 8.9, data engineer is 10.5, AL ML researcher is around 26 lakh per annum, and then several loans also be there. So business analysis they are getting around 9 to 10 11 lakhs per annum. They should have strong knowledge about data visualization, SQL, and then stakeholder communication. So very much strong English communication. And quantitative analysis they are getting salary around 18 to 20 lakhs per annum. They should have very much strong knowledge with maths and statistics with using R and Python, and then finance knowledge also. Marketing analysis, they are going to work with Excel, marketing KPI, A bar B test, and Google Analytics. and they are getting around 6.3 lakhs per annum. Okay. So product analysis, they are working with SQL, Excel analytics tools like Amplitude, Mix Panel, product KPIs, and they are getting around 10.2 lakhs per annum. And then financial analysis, they are working with Excel financial modeling, SQL data visualization, and they are getting average salaries around 6.7. And risk analysis, they are working with statistics and as well as machine learning models, and they are using Python and then or programming. They should have regulatory knowledge, and they are getting around 6.1 lakhs. These are all the initial salary they are getting. Okay. 6.1 lakhs per annum. And then healthcare data analysts, they are working with EHR system, SQL, and then healthcare compliance knowledge, and they are getting around 7.74 lakhs per annum. Okay, so these are the career opportunities. This is very common roles I am just added. Apart from that, there are a lot of roles are available for data analysts. So these are the frequently and commonly available roles in data scientist. Okay, so there is a huge demand in the domain. Okay, so at the end of the presentation, I just want to conclude something like data analytics is a transforming industries nowadays. Okay, it is evolving industries. Okay, previously we are using Excel, now we are using Python, and in future we are going to use some other tools. Okay, for data visualization, previously we are using Excel, now we are going using Tableau, Power BI, and then Python. So in future scenario is some it is entirely different. Okay, it is just evolving industry, and there is a huge demand in the domain to rapid development of data as well as techniques. So the data uh, is more the business and industry data are evolving nowadays. So there is a huge demand to process those data. Okay, so it's supposed evidence that it is evidence based decision making. So it's supposed knowledge mining. Okay, so from the raw data. So ongoing development will continue to expand its impact. Okay, so these are the conclusion I can give at the end of the presentation. So I hope this presentation is giving you some hope and knowledge about data analytics and data science, right? Okay, thank you. If you have any queries and questions, you may please ask.